Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. If you're here because you want to learn to program in Java, you're in the right place. This is the 12th video in the Introductory Programming in Java full course and the third video of Lesson 3, Branching Structures in Java. In the last video, we looked at Boolean expressions and creating them with relational and logical operators. You can use the relational operators to compare numeric and character types, but you shouldn't use them to compare strings. In this video, we're going to talk about why you shouldn't use the relational operators to compare strings and how to correctly compare strings in Java. Let's get right into it. I have a program here called comparestrings.java that illustrates one of the tricky bugs that you can write into your program if you try to compare strings with the relational operators. On lines 8 and 9, we define two string variables, hello1 and hello2, which are exactly the same. They're both hello world. And then on line 17, we assign a value to a third string, hello3, from user input, in which the user is instructed to type hello world. The strings are all printed, and then they are compared using equals equals. And a statement is printed following each comparison, either that the strings are the same or the strings are not the same. Let's run the program. At the prompt, I'm going to copy one of the literal hello world strings from the program, paste it in, and press enter. The program prints all the strings, and they are identical. They are made up of exactly the same characters, but it says that string 1 and string 2 are the same, but that both strings are different from string 3. What's going on? To understand this, you need to understand just a little bit about how variables are stored in memory and the difference between primitive variables and objects. In Java, the primitive data types are the integer data types byte, short, int, and long, the floating point data types float and double, and also char and boolean. All other data types are objects. If we look at our old stats sheet program from lesson 2, we can see 5 variables declared on lines 8 through 12. 3 ints, which are primitives, strength, wisdom, and charisma, and 2 objects, string name and scanner standard in. We can list out all of the primitive data types as I did earlier, but besides that, there are clues that the ints are primitive because int is a keyword and it turns purple, and int begins with a lowercase letter. Class names by convention begin with an uppercase letter, and they're not keywords. In fact, later in this course, you'll learn to define your own data types, your own classes, from which you declare object variables. I'm going to use this program to illustrate how Java memory works. In fact, many programming languages manage memory in a similar way. This is an abstraction. I'm not going to give you all of the details. I'm giving you the details that are relevant to this discussion of the difference between primitive and object variables. We just want to talk about why you generally don't compare strings, or any objects for that matter, with equals equals. Java has, basically, 2 different types of storage for variables, stack storage and heap storage. And if you think one is for primitives and one is for objects, that's essentially correct. If you look at our stat sheets program, ignoring the string args parameter, you can immediately see that we need room to store 5 variables. 3 ints, and 2 objects. We know how big an int is. It's 4 bytes. So we need 12 bytes for the first 3 variables. But objects can vary in size. Even a simple string can vary in size. Remember our character's name, R2 the Barbarian? It could have been just R2. Or it could have been R2 the droid Obi-Wan does not remember owning and killer of the Death Star. We don't know what the user is going to type or how many characters it's going to be. So what happens is Java will allocate that object in the heap, a dynamic memory space that allows for variables of different sizes. And the address of that allocated memory, the address of the object, will be stored in the variable on the stack. Now we know how much memory to allocate on the stack, the size of a memory address. So we can figure out how much memory the stack will take up in advance, while we can't know how much we'll need in the heap until runtime. By the way, memory addresses are often shown as arrows to where the object is in memory. So what does this have to do with using the test for equality equals equals? The test for equality tests 2 values on the stack, And usually it's the values we want to compare, right? If I have two strings, I want to know if they're made up of the same characters. If I have two integers, I want to know if one is larger than the other, if they're equal, etc. So the test for equality works fine to compare primitives because the values are stored on the stack. But when it is used to compare objects, it's still comparing what's stored on the stack. And what's stored on the stack is a memory address. In my drawing, an arrow, not the characters of the string. The equality operator can only compare simple things on the stack. So the only way two strings are going to come up as equal is if the two arrows are pointing to the same place in memory. So here's a picture of our program comparing strings.java. And you might now reasonably be wondering, why are hello1 and hello2 pointing to the same place in memory, but hello3 isn't? That's why this is a difficult bug to detect. Sometimes using equals equals is going to work, like when we compare hello1 and hello2, because they do happen to be pointing to the same place in memory. And sometimes it's not going to work, like when we compare those two strings to hello3, which is the same sequence of characters, but stored in a different location in memory. And without getting into the weeds here, I'll just say that the reason hello1 and hello2 are the same string in memory is because they are literals. Java has an optimization that recognizes when two literals are the same string. So rather than duplicate the memory, it has the variables reference the same string. Now let's talk about how we can properly compare strings so that we're comparing the characters that make up the string, their values, rather than their addresses in the heap. Strings like scanners have methods that are specific to the class and that we can use on objects of that class. Remember that to invoke a method, we use the name of the object, followed by a dot, followed by the method. An example is the scanner's nextLine method, which we're using in our comparing strings program. The syntax is the name of the variable, a dot, and then the method name, followed by parentheses. And what that means is do that operation to that variable or object. So call nextLine on standardIn, which is pointing to keyboard input. String objects have methods for comparing them to other strings, and that's how we should compare them. Those methods are equals, equals ignore case, compare to, and compare to ignore case. You can find these on the string documentation page on Oracle's website. Let's talk about these and look at examples. This program is called Compare Strings Correctly.java, and it starts out the same as comparing strings.java. We have two literal strings. We ask the user to enter that same string at the prompt, and we print three strings. But then, instead of writing hello1 equals equals hello2, for example, in the comparisons, we're writing hello1 dot equals, and in parentheses, hello2. What's going on there? Hello1 is a string variable, so we can send it any string message, or another way to say that is invoke any string method by putting a dot after the variable name and then the name of the method. In this case, the name of the method is equals. The way this method works is we put in the parentheses as an argument the string we want to compare string 1 to. So here on line 26, we're comparing hello2. On line 33, we're comparing hello3 to hello1. And on line 40, we're sending the equals message to hello2 and passing in hello3. Let's run the program and I'll copy-paste the hello world string as before. And notice this time, it says that the strings are the same. The dot equals method will compare the characters in the strings. Each type of object knows, or should know, how to compare objects of that type. So strings know how to compare themselves to another string. Now, because uppercase and lowercase letters are different characters, if I type hello world at the prompt in all lowercase letters, let me do that. Now it's saying that string 3 is not the same, because it isn't. If we want to, we can use dot equals ignore case instead of dot equals, and that will consider uppercase and lowercase letters to be the same. So uppercase A and lowercase a will be considered the same, for example. I'm going to copy the three comparisons and replace them with dot equals ignore case. So we'll still have our originals, but we'll have comparisons that ignore case too. I'll change the message to are the same ignoring case. And if we run that, and I type in the lowercase hello world, we can see that dot equals still says they're different, but dot equals ignore case says they're the same. Which one you choose will depend on the application. Sometimes case is important, and sometimes you want to ignore it. So choose dot equals or dot equals ignore case according to the needs of the application. Now suppose you want to test for a string being less than or greater than another string. First, how do you do it? And second, what does that mean? How you do it is very similar to testing for equality. Instead of sending the dot equals or dot equals ignore case messages, you will send the dot compare to or dot compare to ignores case messages. I'm going to do this one in JShell because it will allow us to do more comparisons quickly. So let's look at a few, and then we'll talk about how it's working. I'm going to define a variable, string name equals Marion. But I want to be clear that you can send a message to any expression that evaluates to a string, to a literal, a variable, or a more complicated expression that evaluates to a string, such as the result of a scanner next line method call. Now I'm going to write name.compareTo, and then in parentheses, I'll pass in Mary. Notice that compare to has an uppercase T on the to. Okay, and JShell tells me -16, which probably seems like a weird answer. What are you supposed to learn from that? If we look at the Oracle documentation, it says that this method will return 0 if the strings are equal, a negative value if this string, meaning the one before the dot, is lexicographically less than the string argument, and a positive value if this string is lexicographically greater than the string argument, the value in parentheses. -16 is less than 0, so that means Marion is lexicographically before or less than Mary. And if you were alphabetizing them, for example, if we were taking this list of notable African American women in computer science and ordering the list by first name, then Marion Croak would be before Mary Jackson. So lexicographic ordering is basically alphabetical ordering, but other characters besides letters can be compared too. You would need to look at the UTF-16 charts to see which values are lower or higher than others. What Java does when comparing the strings is to start at the first character and compare the first characters of the strings to each other. If they're the same, it proceeds to the second characters. As long as the characters are the same, it keeps going. As soon as there are characters that are different, such as when we reach the I in Marion and the Y in Mary, then Marion is before Mary, because I is less than Y, or comes before Y. If Java reaches the ends of the strings and all characters were the same, then they're equal. If the strings are the same up to when one string ends, then the shorter string is less than the longer string. People sometimes find this confusing. They think the shorter string is always less than the longer string. That's not true. The string Z is greater than the string Deborah because Z is after D. So right at the first character, the strings are different and the comparison is over. But if we're comparing Marion and just Mare, M-A-R, notice we get a positive number, meaning Marion is now the larger string. This is because they were equal up until one string ended, so the shorter string is smaller, or would come earlier in the ordering. Now compare to ignore case will compare and not take case of letter characters into account. This might be important because the uppercase and lowercase letters are stored in different places in the Unicode chart, with uppercase letters having lower values. So even though we just saw that Mare, capital M-A-R, is less than Marion, if I compare with Mare, lowercase m-a-r, now Marion is before Mare because of the uppercase M. I find that many students find this difficult to understand at first. These are rules that you've seen used. You've seen alphabetical orderings, but you perhaps haven't thought about all of the special cases in the algorithm for comparison. I recommend you practice with pairs of strings, predicting which will be larger and which will be smaller, and test your predictions in JShell. Most importantly, though, remember that you do not compare strings with equals equals if you're interested in knowing if the values are the same. Remember to use dot equals or dot equals ignore case. I have included an auto-graded exercise in the description of this video so you can practice with this program and some of the comparisons we did in JShell. If you get stuck, come back and watch the video. And as always, these code examples will be available in my GitHub repository. When you're feeling confident with the concepts in this video, you're ready to move on. As always, have fun and keep coding.